Okay, so welcome back. Where we left off, last time we were talking about learning systems. Basic idea with learning systems is you start at some kind of default baseline. Over time you gather information, and then with enough information, you have enough data in place to make reasonably good predictions about whatever problem you're trying to solve. Okay, so some sort of good solution to a knowledge problem. In YouTube, what we have, number one, the set of locally popular videos is the baseline. So whatever data center you connect to, possibly with some differences in metropolitan areas. For example, if you're from Chicago, you might connect to the same data center as somebody in St. Louis, but if you're in Chicago, you might get stuff about the Chicago Cubs, whereas St. Louis might get something about the St. Louis Cardinals. Likewise, things like browser language settings, you're going to probably get a different mix of videos on YouTube if you have American English set as your language versus if you have some non-English language. Now, over time, successive user actions, things like which videos you watch and for how long and in what sequence, are going to give additional information to YouTube. So each return visit, YouTube is going to put all that information together and try to make its best guess about what you'd like to see. Right? That's the sort of learning that goes on. Initially, it doesn't know anything about you. Over time, it learns your actions and uses that to try to predict what you want to see. So, YouTube employs what's called machine learning model. Fundamentally, machine learning is an automated process for making a set of rules about predicting an outcome. Simple case, suppose you have a video that's broken up into 4 segments. Let's call them A, B, C, and D. The person who watched video A is pretty likely to continue and watch video B. The person who watches video B is pretty likely to watch video C, and the same for C and D, right? They tend to be watched in sequence. So what YouTube will do is that, oh, the person who watched video A, yeah, okay, we're going to show them video B as a definite option. Okay, so we can verify this. If I go to YouTube for myself here, and I look up one of our earlier and we don't have internet because that's how that goes. Okay, but if we did, I could go to YouTube and I could click on the first stage of one of my videos. Let's see if we get any luck now. Nothing, something. It says I have internet access. Lies. Well, I know, it's just laughing at me. Click it and disconnect and reconnect. I mean, it's for whatever reason, it sometimes takes a little while. Basically, it has to time out in my old connection, wherever that was. Let's try it again. Ah, there we go. All right. So anyway, if I do, let's say, look at one of my old Amazon lectures, right? Doug Lundquist, IDS 200, Amazon recommender system. Okay, let's do that. Aha! So if I look at recommender system part 1 and I start watching that, ooh, 143 views, that's good. Look at that. It picks out the blah, 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 blah. Okay? It automatically says, okay, this is the one you're going to want to watch next. And the reason is Amazon has enough background data that says people who watch part 1 often go on to watch part 2. Hey, I got a thumbs up on that one. Let's see. Nothing. 100. Yes, I'm a YouTube superstar with my 57 subscribers, my 143 views. No. Well, let me explain how something works. Let me explain how something works. So, approximately, my forthcoming dollars in salary and pension over my expected lifetime is something around the order, let's say 5 million. Okay? Let's say, because I'm gonna live a very long life. Okay? So we're just tossing that out as a number. Now, in order to bribe me to do something for points, basically you need to get up above that 5 million-ish hurdle, because I'm not really what's the word? I'm not temperamentally qualified to do much besides be a professor, right? You put me in some sort of customer service setting. Somebody's going to make an unreasonable request, and I'm going to tell them to go fuck themselves, and then I'm going to get fired. So, like I said, as a professor, I can make it work. A lot of other jobs, not so much. So, yeah, just saying, there's got to be a lot of money involved. So, it's not that I can't be bought, but my purchase price is probably well out of your price range. So, anyway, back to lecture. So, YouTube has a two-stage recommender system. What it does, right, given that somebody's watching a video, YouTube wants to pull out all the videos that are reasonably like it. So, first, it has to pull out a subset of several hundred videos out of billions that a user is predicted to like. Then, ranks that subset and returns the ranked list, right? Displays it in the margin of the screen. What does that sound like? Where have we heard this before? Yeah, that's basically a Google search, right? It's basically the same structure of the algorithm. There's literally potentially billions of web pages that match a search query, and Google's going to return the ranked list to you, right? So a lot of these concepts that we're seeing in YouTube, by now we've gone through Facebook, gone through Amazon, gone through Google. We're starting to see a lot of repeats on stuff. Okay. Other challenges that YouTube has to deal with, things like scale. How do you keep performance going well when YouTube has literally billions of videos? Freshness. How do you make sure that you're only looking at relevant results? For example, one of the problems that YouTube has in this, if they returned a ranked list of video watches, imagine if you have some video that's popular now, but hasn't been popular for very long and only has like 50 million views. It's going to have way less than some video that was very popular 5 years ago and has a few billion views, but hardly anybody's watching it now. Okay, so it wants to incorporate that. So it can't just use the raw number of video counts. It also has to look at trends over time. And then noise, random noise. So things that just don't make a lot of sense, right? For example, somebody is watching a video, right? Maybe somebody is watching this one here on the recommender systems, and instead of doing that, I click on the wrong thing and I get designing a 7-segment hex decoder for some reason, okay? And then from that, maybe I walk away from the computer for a minute, and maybe my 7-year-old son decides to watch a video about pus explosions, right? And he's like, oh shit, that's nasty, right? So there's noise like that built into the system. The stuff people do doesn't always make sense. Anyway, don't watch these, they're vile. Okay, but they exist. Yeah, sure you won't. Okay. Anyway, so those are the sort of problems that YouTube has to deal with. Now, another thing they do, YouTube includes usually a minor random element in its recommender system. So, if you watch a reasonably popular video, okay, what the fuck? Blah, blah, blah. You shut up. Okay, so give me a song that's popular a few years ago. Gangnam Style, excellent. Okay, now, yeah, we'll watch the original, I guess, yes. 140, oh, I thought it would have way more. Yeah, I was going to say, that one? The top one? This one? Oh, I didn't know there was a cartoon element to it. That's what threw me. Okay. So, 3 billion views, right? But what's the problem? If we, let's go scroll down. Here we have some oddball stuff that's related, 25 million. If we scroll down a little bit, we probably start seeing some weird stuff, like 20 people you won't believe exist, like apparently the two-headed woman. Let's see how many views that has. A mere 5 million. Here's this. 31 million. Wow, that's more than I expected. Okay, we scroll down a little bit. Eventually we'll find some oddball stuff, probably, that is... yeah, there's a lot of stuff here, and a lot of them are really popular, but we usually find a few that are like oddball stuff, like, but here maybe not so much. Maybe our big one that we found is that 25 million. Let's see. Now You See Me Scene. This might have less. Then again, it might have way more. 71 million. Well, we're not really winning today. All right. Okay, but the point is, YouTube is going to do some experiment stuff, right? It's going to put some random things in its recommender system now and then. So, reason why number one, it's going to try to suggest content that it thinks is interesting but hard to find, right? Maybe stuff that you wouldn't otherwise see. Number two, lets trending videos compete against older ones. So if it's just going to look at older videos, right, that have higher video view counts, then people are going to only see old stuff. And in fact, we saw a lot of that, right, just looking here at YouTube at the videos that came up, right? So all the ones here, right? Many of these songs are old enough that I've heard them. So, right, we got, yeah, some Shakira, Crazy Frog, whatever, right? Okay, Aqua, that was like late 90s. So, anyway, some old videos show up here. Okay. Another thing, gain more knowledge about user preferences, right? So if YouTube only has connections of the same people watching the same cluster of a few videos over and over, it doesn't learn much. It wants to mix it out a little bit and say, okay, people who like this also like that. Basically get some random connection points. And last, it wants to converge quickly to preference changes, right? So if it's a video that's popular now, it wants to get connections on that, right? So if it puts in, you know, a bunch of videos in the margin, some of which are old, some of which are new, but have a lot of videos views in the last few days, and people click on that, then it's very quickly going to converge. So YouTube says, oh, people who watch Gangnam Style now want to also watch this video that's current. Okay? Yeah. Anyway, bigger purpose, just like Amazon with its recommender system, it wants to break out of that kind of circular feedback loop that can happen. So with Amazon's recommender system, right, you have the idea that people who purchased this also bought that. But if Amazon only shows in the recommender system the highest likelihood purchases, what's going to happen is those purchases that already have a high correlation, they're going to get bought more often, and it's going to keep them popular relative to other things. Amazon needs to mix it up a little bit. Okay, so without that sort of random factor, recommendations basically become trapped in some kind of inertia where the recommendations you get are always for the same stuff, and then eventually people stop using them. Okay, so that's it for how the videos are selected. We'll talk a little bit about database systems. So first of all, YouTube has a special custom database system that would not really be feasible to do on ordinary relational database platforms. So this article here is about Oracle. If you haven't heard about Oracle, they're a big company that does this kind of relational database stuff. So the quick thing, oh, you can't see what I'm doing as usual. Now you can. Okay, so you can scan through all this and basically say, here's the total. If you tried to do YouTube, and this is from several years ago, what was the exact year? 2011. So the numbers are a little off, but it would actually be a much worse comparison now. They say if you're trying to do this on Oracle setup, it would cost about $600 million versus about $100 million doing some kind of open source platform, okay, and just paying for the hardware. So about $500 million several years ago, surely up to at least a couple $2 billion now in cost difference per year. All right, so the key takeaway, Amazon, YouTube's system would not be feasible to set up in an ordinary relational database platform. It would cost way too much. Some other interesting reading, this is about some things need to be consistent, a lot of things don't. Okay, so this is about eventual consistency. There's other stuff in here, but if you want to look at it, okay, I'll bring this one up too. So there's a bunch of topics in this article, but we'll get the few big ones. So number one, approximate correctness. In many cases, the numbers you give don't need to be exact, okay? So, real world example. Suppose you have a data center that has a lot of users connected to it, right? You have one video that's popular and a bunch of users can make comments on that video. But there are also a lot of people accessing it simultaneously. In fact, the video is even so popular that it's replicated on data centers all around the world. Well, here's the thing. If you're writing a comment on that video that doesn't get seen for maybe half a second, nobody else in the world is really going to care. They're not going to know. They're not going to know who you are. Whatever. Your comment hasn't been posted yet. On the other hand, if you're the person who's posting the comment, you want to see right away that your comment shows up in the comment block so that you know it got accepted, right? So basically, your system doesn't have to have globally consistent transactions. Before you enter in something as trivial as a comment on a popular video, you don't need to make sure that everything else on every other copy of the system is ready for that action to happen, right? You just need to have it eventually be consistent some point down the road. So as they say here, not every transaction is a financial transaction. If it's a financial transaction, yeah, you want things to be globally consistent. Every copy should show the same stuff. If it's something like doing a Facebook like on an image or a YouTube like or leaving a comment, not so important. Okay. Other stuff. Cheating. How to fake data. So this, they say here, the fastest function call is one that doesn't happen, okay? So imagine if you have a monotonically increasing counter. That means you have a video view count that's going up at the same rate, okay? So it's a popular video, maybe it's getting 2 million views per hour. Well, you don't need to keep exact track of each and every view. You can just say, all right, we know what the count was an hour ago, or like 5 minutes ago. We can prorate that time to say, well, if it was 6 minutes ago, it's going to get 1/10 of an hour, 1/10 of 2 million views, so add on about another 200,000 views, and apply some random factor to it to make it look pretty much normal, okay? So they say here, or you could do a transaction once in a while and update it by a random amount, okay? And as long as it changes from even to odd, people will probably believe it's real. Because nobody's going to get too bent out of shape if in, some 10-second interval the number of video views is out of whack, right? As long as it gets to be correct by the end of the day, that's fine. Okay, so there's some interesting stuff there about, like I said, when data needs to be exact and when you can cut some corners. All right. So, YouTube's video system is called Vitesse. And if you know French, you know that vitesse with an extra E at the end is the French word for speed. So that's what it is. It's named after, it wants to be fast. So YouTube's core database is a scalable extension of MySQL called Vitesse. MySQL is a relational database platform widely used. The big things about Vitesse, number one, yeah, it is a relational database system, but it has some extra features built in. One of the big ones, avoiding query duplication and automatic query parsing. So what do we mean by that? Well, quite often you will have videos that form a subset of other ones. So suppose you're looking at, I don't know, what do we look? We have a big pool of videos, and we have top videos from, I don't know, 2010s, okay? That would necessarily include as bubbles, top videos, top from 2011, top from 2014, top from 2018, right? Close enough. So, if YouTube has the results for this query already cached and ready to go, then it doesn't have to search its entire database to find this or this or this, right? It can just look up, oh, somewhere in this, right, I know that the top videos from 2011 is going to be some subset of the top videos from the 2010s, okay? It's designed to do fast things like that, so as far as possible, video requests that come up don't overlap. Likewise, it can do just like Google's indexing system, right? Suppose you, let's say, who's popular today? Let's say Katy Perry, okay? There's a whole list of Katy Perry videos, and if people want to pick particular ones, those are already stored in there, right? Videos by her. So, I don't know, maybe she's not as popular as she used to be, but that's fine. Everything goes up and down. Okay. So that's what we mean by that when we talk about avoiding query duplication. You don't want to run the same queries through the database, and you like to be able to parse them apart to see which queries form subsets of other queries that you might already have the results for. Makes the system operate faster. So, second question, why is a relational database system even viable, right? Everything we've talked about up till now says, hey, if you have data that's going to be wildly divergent, like videos, right? Some videos are very compact, other videos are very large. how does a relational database make any sense at all? Well, good question. First of all, metadata. Metadata is always going to be standardized. It's going to have things like the video title, the artist, the number of views, when it was created, the file format, whatever else you might want to have. All that's going to be standardized, things like the frame rate even. Second, when the videos are stored, remember Dash delivers video segments. So the video should already be segmented before you even start viewing it, right? YouTube doesn't want to be in the position of saying, there's this giant video it has in storage. Every time some user shows up and wants to start watching it, it has to resegment it. YouTube already wants to store the video in segments. Well, guess what? Those segments can be fitted to pretty standard sizes, right? Based on the window size and the frame rate and the pixel resolution, all that, okay? It can keep those as standard size objects. So both of those data types can actually be stored in relational databases with pretty high utilization and performance, not like ordinary unstructured documents that we've dealt with so far. Okay, but that's only part of the question. Part of the question is why a relational database is viable. That's why. What's the other half? Well, why not just use NoSQL? Why not use something like a key value store? Well, short version, YouTube has to consider things besides just storage. First of all, compression, right? YouTube stores the videos in segments, but it also stores them compressed. Because same reason, just like it doesn't want to segment the video for each unique view, it also doesn't want to have to run the compression for each unique view. It's going to store those segments in a compressed form, okay? Now, if you store the entire video as a data blob, basically in some sort of key value item, and the value was the entire video that might be up to a couple gigs, if you did something like a non-sequential search, it would be very slow. Because why? Because in order to figure out where you need to get to at that point in the video, you'd basically have to decompress it. Or you'd have to have some secondary index that tracks all the intervals of, how far into the video you want to get for different compression formats. So that would be a big hassle, and you basically don't want to do that. Second thing, on YouTube, table joins are often inherent in the video search process. So what's a table join? What's a table join? We've talked about this several times. Fair enough. Anybody remember what's a table join? What makes relational databases in some sense better than NoSQL databases? What can relational databases do reasonably well? Yeah. Yeah, that's the idea with the table join, is basically we're doing some kind of query involving multiple tables, right? There's different kinds of joins, but that's the key thing. We're bringing data from different tables together, okay? And often that's inherent in the video search process. So if you want to look at videos by a particular artist or from a particular album or videos uploaded by the same user, all that data could be scattered around all kinds of different tables, okay? So YouTube wants to be able to answer those kind of queries because that's what users want. And you might even have unrelated videos in some sort of mix setup. Now, contrast with Facebook's Haystack. So Facebook, you don't have that sort of capability to run queries across tables, right? Basically, you can go to somebody's profile page, and over there you'll see, they have stacks of photo albums. You can click on a photo album, download that set of images as one blob, but you can't on Facebook run some kind of query that says, show me all images posted by people in November 2019 if the user was in Chicago and the location was in Chicago, right? There's a reason why Facebook doesn't have that kind of capability, and it's because of how the data is stored. If they stored it the same way as YouTube, like if they stored images in segments in a relational database, yeah, they might be able to do that, but they don't. Okay? All right. So that's all of our database stuff. Questions on any of this? Learning systems, experimentation, databases. All right. Okay. Well, the rest of what we have to talk about today then is cookies. So HTTP cookies, or more commonly, just cookies or browser cookies. So cookies are small files, basically text files, stored in your web browser by a lot of sites if you let them. In general, you get one cookie per profile and browser combination. So if you visit a particular site, that site is going to put a cookie on your machine. And if you visit that site again in another browser, it's going to install a second cookie on your machine. If you visit that site again from a different machine, that site's going to put another cookie on that machine. So, in general, also, they don't store information to identify users across devices. So, cookies are basically one site, a particular cookie is for one site used by a particular user in a particular browser. So, example number one, if I have Chrome and Firefox on one laptop and I visit the same site, they're going to store cookies separately. Example two, if I run 2 copies of Chrome on different laptops, each copy of Chrome is going to get its own separate set of cookies. All right. So cookies have some standard elements. I mean, basically, they're a text file with a given size, but sites can specify what's stored and how it's interpreted. They can basically put in whatever they want. And data is typically stored as either plain or encrypted text. A lot of times for security reasons, they'll store it as encrypted, but it could be either. And if you want to, you can look inside for Microsoft Edge. They should be in the App Data, Local, Microsoft, Windows, and Internet Cache for Internet Explorer cookies. Different browsers will keep them in different folders. Okay, so here's an example cookie file. This is from one of my own machines from a site called udacity.com, and I twisted it up a little bit so you can't actually use it. But here, for example, instead of an A, I put in a Q, and I, altered some letters in there. Anyway, but if you look at it, it's a bunch of scrambled encrypted data, right? It means something to Udacity, but if I look at it, it doesn't mean anything at all. But this is about the amount of data that you can get in a 3K cookie file. So roughly speaking, 1K is about 1 page of typed data, typed text. Okay, so how do cookies work? Well, when I visit a site, if I let it, it's going to install a cookie on my device. Okay, and that cookie is going to have session information about me. Basically, number one, the fact that I'm successfully logged into the site, and number two, any stuff that I've done on the site that the site wants to track. So, if I visit other pages on that same site, that cookie becomes my proof of login. That's how come if you go to different pages on YouTube, it still remembers that it's you even though you don't continuously log in. Same kind of thing on Facebook. When you go to different pages in Facebook, it still remembers it's you and you don't have to log in on every page. So, for subsequent visits, anything that gets remembered, right? This is one of the things, for example, might allow me to stay logged in across sessions. So I visit YouTube one day, I do some stuff, I come back the next day. If the cookie session has not expired, YouTube remembers that it's me and I don't even have to log in again. Okay? So, example cookie data, stuff that's typically stored, user ID and passwords, and obviously passwords, you want to keep those encrypted in most cases. Site preferences, so anything that you've set up about how you want YouTube to be. Recent user history, like any searches you've run or any pages you visited, any videos you've viewed, any positions of the video, like if you watch something halfway through, YouTube can remember that. On retail sites, things like your shopping cart contents. So if you go to Amazon, you add something to your cart, you come back again 4 days later, it'll remember, hey, you still got something in your cart. Okay? Those are the kind of things that you store in cookies. Now, why are cookies needed? Well, short version, many web applications are what are called stateless. Stateless means the application doesn't record any information about the session state, about what's going on there. So, stateless applications by themselves don't track information about users. Simplest case of that is basically retrieving a basic web page. So you go to a web server, you say, give me such and such page. You don't have to log in. It just delivers it to you. It doesn't need to know anything about you. It just delivers the web page, whether it's your 10th time visiting the site, whether it's your first time, it delivers the page the same way. And that's how early HTTP worked, right? So originally, HTTP, Hypertext Transfer Protocol, that's the protocol for sending web pages over the internet. It was stateless, but since it's been evolved to include some stateful features like cookies. Okay, so a stateful application does group user actions together into a session, and the most common mechanism for doing that is cookies. So, typically a server receiving requests over the internet doesn't know if any of them have the same source. So it just, as every request comes in, the web server responds to them and doesn't check to see if those requests are coming from a common source. So, if they wanted to keep that knowledge, you could keep it on the server side. For example, you could update the database for every user action that happens. But it's generally way more scalable to do that on the client side. Because if you did it all on the server side, you'd have to have some big database. If your site is as popular as YouTube, you'd have to constantly be updating it, and that would really slow everything down, or you'd have to keep a lot of hard drive copies on hand to make sure that nobody gets locked out, so that all the updates can happen pretty quickly. So it's much more scalable to do this on the client side, track the information on the client side, which avoids all these problems around concurrent access. Okay, so cookies are needed. Number one, they track information about sessions. If you tried to track all that information on the server side on a very large popular site like YouTube or Facebook, it would be a big headache for them. So they'd rather track that information on the client side. Basically, when you download a web page from YouTube, you go click a new video, it looks at your cookie, sees who you are, updates that information in your cookie, and then, formats the page to be shown according to whatever preferences you have. Okay. So, HTTP cookies are limited to about 4K of data, which for some applications is a lot, but for others not nearly enough. So YouTube, for example, typically maintains multiple cookies per user for doing things like tracking session details, information about recently viewed videos, whatever current segment they're on, how far along you viewed them, stuff like that. And it holds these preferences even if you're unlogged. So even if you never log into YouTube, it can still put a cookie on your machine and track you. So it's just not going to track who you are in the sense that you have an account there, but it is going to track information about what you've done there. Now, sometimes other objects have been designed to act like cookies while remaining sort of concealed. So one thing like that was what was called a delayed cookie. Delayed cookie is a long-term cookie that isn't associated with a particular session. So basically it keeps information across sessions. And a lot of those were associated with Flash Player. So a little article here about that. So some people, out of concern for security or other privacy, other issues, they wanted to opt out of cookies. So YouTube had a new cookie feature that sounds like it doesn't use cookies. But guess what? Yeah, it still uses cookies, different kind of cookie. So it still stores information about your sessions, but in a different way and a different place. And the funny thing about it is, in particular, right, normal web cookies can be managed by preferences dialog. You can clear cookies, or you can do it to your control panel and clear them. But Flash cookies could remain on a computer indefinitely. There's no mechanism to set an expiration date on them. In fact, the only way to delete them was to visit a special web page on Adobe's site. So even though you thought you weren't getting cookies, guess what? You were getting cookies that actually tracked more information and were harder to get rid of. So anyway, okay, you have this, that's fine then. Okay, now talk about cookie security risks. So there's clearly some information inside a cookie that could be of use to bad guys. Things like session credentials that you could use. If you copied that, you could use that to prove that you were someone else. So, interesting little bit of history. When HTTP cookies were first introduced in the mid-90s, number one, they were unknown to the non-technical public. Unless you were like a computer guy, you had no idea what cookies were or how they worked. So, second thing, cookie acceptance was the standard browser option. So if you had the early versions of Internet Explorer in the mid-90s, yeah, it was automatically set to accept cookies. Why? Because it made going to sites run a little better. However, once these security issues started to become apparent, the sense that a bad technology had been forced on customers who didn't know any better made a lot of people kind of freak out about cookies. So, number one, because information stored in cookies is potentially sensitive, cookie data is often encrypted, right? The big stuff there is username and password, as well as session tokens. You don't want people to just be able to grab all that. So different ways that cookies can be attacked. Cookie tampering, you can mess with what's in the cookie, make it unusable by the standard user. Second, hacking the cookies, you can extract the information that's there, use it to impersonate someone. For example, if you have a session token like some long string of garbled text and it's just there in plain text, a bad guy could grab that, use that, create a new cookie using that, and pretend to be you. Other stuff, forged cookies. So if you just make a copy of an entire cookie and use it as if you're that person, yeah, that was a thing. So Yahoo warning users that hackers forge cookies to access their accounts. So if your account is compromised, for example, something in Flash Player, they can access your cookies on your browser, and they can grab, if they can read that data, potentially they can make a copy of it and use it elsewhere, and thus they can hack your account that way. So, but the problem is this: without cookies, basically you still need some kind of mechanism to access multiple pages in a site without logging in. Or you have to log in on every page of every site, which is a colossal pain in the ass, and nobody wants to do that. So even though cookies do have some vulnerabilities, yeah, most people have chosen to remain on the side of using cookies and elevate their security in other ways. Okay, so cookie types, just a couple more slides. So cookie types, there's three basic ones: first party, third party, and super cookies. So we'll do an image for this. Okay, so here, first party cookie. Okay, I go to Amazon, they put a cookie on my machine. Oh, you can't see it. Yeah, we'll get there in a second. Okay, that's fine. Okay, I go to Amazon, they put a cookie on my machine. When I visit Amazon again, Amazon uses it to get my recent history. Okay? So that's what a first party cookie is. Now a third party cookie, okay, used by other, okay, let's say placed on my machine by Amazon, but used by other sites, such as blogs running Amazon Ads API. Okay? So, with a first-party cookie, I go to Amazon, Amazon puts a cookie on my machine, it only gets used when I visit Amazon. Amazon's the only one that uses it. A third-party cookie, I visit some site like Amazon, that site puts the cookie on my machine, but it's there for other sites to use. And the common example of that is when you're running ads. So, right? So when I go to one of those random blogs, I could see ads around items I placed in my Amazon shopping cart, but didn't actually buy. Okay, that's the sort of thing you can use third-party cookies for. All right, super cookies we'll talk about in a minute. Yeah, zip ahead here. Okay, so first party, used by the same website you're visiting, and generally done to improve site performance for you, minimize network traffic for the site. All the reasons we've talked about why they like cookies. Third-party cookies, used by the source to track your actions across other websites. So, Amazon ads use third-party cookies. When you go to some blog that's running Amazon ads, you can see recently viewed products on non-Amazon pages. Okay? Last one, super cookies. Super cookies are not true HTTP cookies. Instead, what they do is they aggregate information across cookies. So, gather information about users' internet history across sessions, websites, even browsers. For example, Google could aggregate information across multiple sessions and even multiple browsers to show how you use Google apps. Okay, so that's what super cookies are, is basically they aggregate the information that's in other cookies. All right. What's on the horizon? Well, first of all, cookies are still useful, but not as useful as they were in the 90s. Number one, users typically have multiple devices these days, right? Back in the 90s, if you had a computer, you probably had one computer and it was your desktop and that was the only one you ever used. Nowadays, people might have a desktop and a laptop and a tablet and a smartphone, right? And they might have older ones that they use sometimes. So because users typically have multiple devices, each cookie is only going to have partial information about that user. Second, a lot of users are more privacy conscious these days, so they periodically erase cookies. Some users even block them altogether. So the information that exists in a cookie, not only is it only a tiny fraction of your online activity, it also tends to exist for a much shorter interval. So What's coming out to replace cookies? Something called fingerprinting. So basically, even if you don't give permission for sites to recognize who you are, there's a fair amount of information on your machine that they can actually use to do that. Things like what hardware you're using, what browser you're using, what operating system, and all that stuff does a surprisingly good job of identifying machines uniquely. So here's a little bit of research from about 5 years ago. Okay, this was an article about the web never forgets persistent tracking mechanisms in the wild. Okay, so if we look at this, I'll zoom in a little bit. Okay. Oh, you can't see it. Yeah, of course. Okay. I can see it. All right. So, okay, web never forgets. So we present first large-scale studies of advanced web tracking mechanisms, Canvas fingerprinting, Ever cookies, and cookie syncing. Basically this one, Canvas fingerprinting, recently developed form of browser fingerprinting, not previously been reported. Their results show that over 5% of the top 100,000 websites use it. Again, that was 5 years ago. There were already other techniques. You can bet that the numbers have gone up substantially in the last 5 years. So even if you have cookies disabled, even if you never, or you otherwise always delete them quickly, yeah, sites are still trying to remember who you are in various ways. Okay. So I guess the takeaway from that is your online activity is not nearly as hidden as you might think it is, even if you're using incognito mode, stuff like that.